This video is made possible by the Hawaii Institute of Geophysics and Planetology, the University of Hawaii Department of Earth Sciences, and the ARCS Foundation of Honolulu. Mahalo. The sun and the moon together create chemical compounds on the lunar surface. I'm looking for something that's predicted chemically, but has not yet been detected. Aloha mai kako. I'm Chiara Ferrari-Wong, a University of Hawaii PhD candidate in Earth and Planetary Science and 2021 Toby Lee ARCS Award recipient. Hydrocarbons are organic chemical compounds composed most basically of hydrogen and carbon atoms. You've probably heard of a simple one called methane. It's made here on Earth through the breakdown or decay of organics. Some mechanisms might include the decaying of plants and wetlands, burning of organic materials like wood, and livestock emissions. Methane was first detected in lunar samples in 1971, and in 2016 it was detected in the lunar exosphere. But unlike Earth, production of methane cannot be attributed to a lunar dairy industry. Instead, the evidence points towards the solar wind, a stream of charged particles, mostly hydrogen and some others like carbon, that are released by the sun's upper atmosphere. On Earth, our magnetic field deflects these ions, but since the moon lacks a global magnetic field, they can become implanted in the surface where they can undergo chemical reactions. We know that methane on the moon exists, but we also predict a variety of other compounds whose reactions are possible on the surface, such as alcohols and alkanes. But unlike methane, these predicted compounds haven't yet been confirmed. This is where the plot thickens, because many of these predicted compounds have low vapor pressures and might not stay on the surface long enough for us to detect them. Just think of water on Earth and how it evaporates quickly on a hot day. But there is a mechanism that might be able to keep these compounds on the surface. Micrometeorites are small impactors that can strike the surface of the moon at high speeds. When they strike, they melt the surrounding soil, forming glass on the surface and possibly trapping compounds like a fly in amber. If this is the case, then we should be able to detect the trapped hydrocarbons on the surface of the moon. Most organic compounds have a unique spectral absorption feature in near-infrared light, known as the carbon-hydrogen stretch. I'm looking for these signatures using ground-based observations at the NASA Infrared Telescope facility on Mauna Kea. Our primary goal is to determine if there is a carbon-hydrogen absorption feature that we can detect on the surface of the moon. If we can't find one, it might be because the compounds exist in smaller amounts than are detectable through our observation method. If we do find an absorption feature, we'll want to quantify the amount of hydrocarbons detected, as well as where they are located. Who knows what we'll find? You'll just have to stay tuned.